Okay, the second derivative in concavity. On a graph, graphs can look different ways, depending on whether they're concave up, such as the bottom of a bowl, like we have in this first section of the graph, or concave down, like we have in the middle section, and again concave up on the right-hand side. So concave down, I visualize this as looking like the top of an umbrella, while concave up is going to look like the bottom of a bowl. All right, so when we're looking at graphs, it's important to be able to understand whether they're going to be concave up in sections or concave down. What this is going to be based on is the second derivative. All right, if the second derivative is positive in that section, then it's going to be concave up. If the second derivative is negative, it's going to be concave down. So let's take a look at an example. If we had an epidemic, and it started, you're a member of Congress, and you have to decide what kind of measures need to be taken. Should we be very worried or not be very, very worried? What we can look at is the number of cases and how these are changing over time. So they started out, it's going up, and now we're right at this point. So the rate of change is illustrated by this tangent line, the blue line. Or it could be happening like this, where we're increasing. Again, we get to the exact same height, right? So the exact number of cases. The tangent line is still the exact same in both these cases. And let's bring this over here so you can see these are the exact same. So that rate of change is the exact same in both cases. We have to figure out, should we take drastic measures or not take drastic measures? Well, that determination could be based on whether it's concave down, such as this one, so we think it's going to not accelerate more quickly and the cases are going to go up more quickly, or if it's concave up, in this case, even though we have the exact same height, the exact same number of cases, it looks, because it's concave up, like the numbers are going to explode over the next amount of time. So in that case, if it was a concave up graph, you're expecting them to rise more quickly in the future, therefore more drastic measures should probably be taken. So the second derivative, a little bit of notation here. Basically, the second derivative is just taking the derivative of the derivative. All right, so a lot of times we have to start with the original function, take its derivative, the first derivative, and then take the first derivative's derivative. All right, so that'll give us f double prime of x, or y double prime if you want to read it that way, or our Leibniz notation looks like this. All right, and as we mentioned up above, all right, if the second derivative is positive on an interval, it's going to be concave up and look like the bottom of a bowl. And if it's f double prime is negative on this interval, it's going to be concave down, look like the top of an umbrella on a graph. All right, I hope this helps out, understanding a little bit visually how concave up and concave down look.